All right, everybody, welcome to Brighter. So this weekend, Tesla dropped a brand new video of their Teslabot Optimus, and it is amazing what it can now do. And so we're going to go through some real new insights. Scott Walter is with us today. He's a co-founder of two robotics companies, and he's got some really good information he wants to share now that he's had a chance to think about it. Welcome, Scott. Thank you for joining me.
Thank you, Herbert. Glad to be here. And this is one of my favorite topics.
It is. We are been doing so many videos on bots, and we're always on top of what happens when the Tesla bot has new capabilities, and they dropped it. And just like we've been saying, it is improving so quickly. So let's get right to it. Let's go look at the video, and we're going to go and walk you through this. Scott, go ahead and tell us what you're seeing here. I'm going to go ahead and play it, but speak right over it.
Okay, so the video is pretty much in three sections. The first section is looking at robot calibration. So the robot is trying to understand its actual body positions. If we just pause it for a second right there, we'll begin to sort of see what they're talking about here. So they're using vision only to get the joint position encoders. So everyone might be wondering, like, what is joint position encoders? What does that mean? Well, the robot is made up of all these different joints that we know, which act like hinges or ball and socket kind of joints. And pretty much you need to measure the angles of the deflection of each one of those joints. And you could think of it as like, well, you could put a protractor out there and measure what the angles are. But we do it electronically. And the way we do it electronically is using these encoders. So the joint position encoders is telling us the actual position that the elbow might be in, or the shoulder, or the fingers, or anything else. And in order to command the robot to go to a particular position, you need to tell it the joint angles you want it to go to. Now, actually, the joint angles get broken down into encoder pulses and everything else. But from the standpoint of anyone doing the math, they're going to be thinking of it as degrees. So I want to have my elbow at 20 degrees, and then I want to have maybe my wrist at 30 degrees. And the reason why I want to do that is there's some position in space. And of course, spatially, I know where that is in the Cartesian position. There's like some X, Y, Z. And I have a model that tells me if I give these joints as an input, it's called a forward kinematic model, I will get these Cartesian locations as an output. So, and then you can reverse it the other way that, hey, if I need to get this particular target, X, Y, Z, what are the joint angles I need to get? But in order for that to work, it means your internal model, which is ideal, needs to fit the real world model. So you need to get the parameters from the real world model and bring them back to your idealized model and update that idealized model to come closer to matching reality. And that's a typical calibration step. Now, a lot of people may be familiar with this calibration step because if you use FSD, you may notice when you first get your car or first have it, you have to drive a little bit for the cameras to calibrate, to get an idea of exactly where they are. So it has an idea spatially where everything is actually situated. And Optimus is going to have to do that as well, but it's going to have to do it in two steps because the first thing it's doing is it's using its vision the same way a surveyor would use the cameras that they have to measure your property or something like that. And the way surveyors work is that you need to have 2 points of reference that kind of looking at the same point in space. And you need to know the distance between those two, what are these theodolites that are measuring that same point, because it's kind of a stereoscopic view. And so they usually have a fixed distance between them. And the same thing with your eyes. If you know the distance between your eyes, when you look at the same target out there, in principle, you can calculate the XYZ position. Now, Optimus has all those cameras, on there that are able to see things from slightly different points of view, and you can figure out the actual location in space using a little bit of math. And mobile phones, smartphones do this now. I mean, your cameras are able to do that now. We're able to take pictures and get an idea of what your environment is. So you're able to do a kind of environment mapping. The way that works, and if we look back in there, you'll notice there are some reference points there. So it's not just looking at its hands, it's looking for some landmarks on the hand. So you see those dots is where it's recognized something that it can see throughout all the images. And it could be like the edge of the wrist or somewhere in the fingers or on the knuckles or something like that. So once it kind of identifies these features that are very easy to identify because they're like an edge or a corner or something like that, it then tracks them a little bit in space. And from that, it now knows the position in space. And then it says, hey, do those positions correspond to the joint angles I'm currently reading from my encoders? And if it's like, no, there's a mismatch, then it goes through a pretty simple fitting algorithm to figure out how to update what we call the joint zero positions. So the idea of a joint zero position is really pretty simple. If you have an analog clock, and let's say all the hands are pointed right up, your hour hand and your minute hand are pointing to midnight. But you take the watch face and you just kind of randomly spin it around and it's pointing at some random time during the day. So maybe it's saying it's like 5:15 in the afternoon. But it's not 5:15 because it should be pointing at midnight. So that means there's a mismatch between the measurement system you have and where things really are. And when any robot is put together, you really don't know where those encoders are. So you're trying to find the zero reference or some sort of common datum to get that correct. And so this is very important to get any robot to work. And this is very basic to any industrial robot. So it's not just new to Optimus. It's a very fundamental thing. And the way to solve this problem has been known for a while, that you need a measurement system. And that measurement system can be bringing some complicated external stuff to do all that measurement. Or since you've got built-in cameras, why not do it automatically? So this is very nice to see that not only have they solved that problem, but they solved it internally. And it's also to make sure that Optimus is going to update itself maybe every day, because those encoders could slip. Maybe when you power down or something like that, it loses some sort of reference or it bumps into something and something gets a little bit out of whack. So it's constantly going in there and updating it. So bottom line, what this means is this is important to proprioception. The idea of Optimus knowing exactly where it is in space just by knowing what its joint values are. And you remember what proprioception is?
Yeah.
Yeah. So it's our internal model. It's
knowing where things are.
We can close our eyes and really be able to visualize where our hands are in space as we move them around. We don't actually need to look at them. Now, when we look at them, we're able to update that to make sure it's actually where we think it is. So a lot of times it might be kind of close to where we think it is, and the vision system makes sure it actually is where we want it to be. So it doesn't mean you remove the vision system completely. That's what industrial robots do. They think they have such a perfect internalized model that they can go wherever they need to in a particular space, but that's assuming the thing they're trying to grab is at the location that they believe it's at. And if it's somewhere else, it's going to miss. So it's very important to know really what your internal reference system is to be able to do it. So that's the first part of it. And and one of the things I said is that I wasn't surprised to see this. I was expecting this, and so, yep, okay, it's there. So they have an internal model, they calibrate everything, and once they do that, it means when it goes to grab the block, it's actually going to grab the block and not going to grab air. And this here is the next, which is really quite interesting in the fact that it is pretty much vision in and then output through neural nets without any heuristics. And that is why you're seeing such smooth movement, and you're also being able to see the robot to quickly adapt to changes in its environment. So I refer to the fact that it's able to update dynamically. The other thing to note, very early on in this video, it says it's at 1.5 speed. So if you think things are running a little bit fast or something like that, it's at 1.5 speed. Okay, so that's out there.
That's not terrible.
They're not hiding anything. They're not trying to trick anyone. It's 1.5 speed, but still, it's very smooth, very natural looking movement.
And then just to reinforce this thinking for those who don't know, they fed it video, and the video showed the blocks. They want to move the blocks, and then that's it.
Yeah. So they somehow trained it. It's not clear how they persuaded Optimus to play this particular game, but it's been trained to do a lot of different tasks. So it understands how to move its arms. And at some point they gave it a command. Now, we don't know if they just typed in a command somewhere and it went ahead and did it, whether they sort of demonstrated something and figured out, or whether they just spoke to it. So the impression we have is that the game it's playing is it knows that it wants to take the blue colored blocks and put them into the blue tray, so to match the color. But you notice the other colors doesn't match. So I'm not sure how Optimus is inferring that there, but it wouldn't be surprised if they're doing it, because we already saw Google doing something very similar. Yeah. This idea that they would be giving it some sort of language instruction, and which is probably typed anyway. So it's not necessarily spoken, because otherwise it would have, because I don't think Google actually had something that you said it. I think they typed it in, and then it tried to figure out what it is you want me to do, and that it was able to do tasks that it had not been trained before in first. So if you remember in the Google example, was they had a bunch of flags on there and they said, move the banana to Germany. It'd never been taught that before. And then it just kind of realized it knew what a banana is. It saw the flags. It realized that the flag that represented Germany, and that your intent must be move the banana over to there. And so that's the thing a large language model will do. And then the large language model is going to feed into Optimus, and Optimus has to go ahead and play the game. And so then when Optimus is going ahead and deciding it's going to grab a particular block, it's assuming it can get there, and then it sees conditions change. And remember, the same thing happens with FSD all the time. I'm trying to drive down the street, and you don't assume it's going to stay the same. Cars are moving here and there and everything else. So you always have to sort of change your plan along the way, depending upon what's happening. So right there, it's got a particular target it has to go for. And look at it. It's almost like, hey, I have to avoid a collision. There's another car getting in my way or something like that when it goes to pick. So we see the game being played by the human to sometimes move the blocks and sometimes even hide the blocks from Optimus, and then it has to make a decision on what to do next. Now, it's not perfect on the picks. So there, we get the little game, realize it has to put it back on in there, and things are being moved around. And it then sort of decides if it can't pick a particular one, it changes the target right away. And if it can, it goes ahead and gets that target. And the other thing that's interesting is that when it notices it makes a mistake, it writes. Yeah. Now, what I really liked about that is not just that it righted it up, but notice how it decided to pick it from the side to do that. That's like the correct way, because if it tried to pick it the other way, it probably would have been a much harder move for it to get around to get it right. So it sort of knew that that was the right way to do it. Very impressive. Now either that, or it's always going for the top of the block, and the top of the block is the side. So it decided that's where I'm going to pick it, but it noticed, oh, that's wrong. Now, in many ways, Optimus, and I think it's the same thing we saw with the Google bot, it's sort of picking a random position for its target. So it's not like when they put the banana on the German flag, it put it right in the middle. It made sure it landed somewhere on the paper. So a lot of times, like if it's on the tray, that's good enough. It's not trying to put it in the center of the tray or a particular corner. And so, one of the criticisms that I would have with Optimus here is like, well, wait a minute, why don't you space out the blocks a bit more so they're not getting in each other's way and bumping and falling over in the first place. So that's my criticism. And of course, that's been turned around the other way. So a lot of people, rather taking that criticism, are saying that, wait a minute, why did that block move? It's like, the reason why the block moved is because Optimus tried putting the two blocks together and it hit one of them and it bounced and it deflected off. It's
possible that they showed a lot of videos. And if you see humans doing it, we don't try to, some of us might try to put, nicely arrange. Most of us are just like putting it away, right? Because you're doing it fast.
Sometimes we have, exactly. So sometimes we have a pattern that we want to follow, but a lot of times it's just pile a bunch of things over there. That's good enough. It doesn't really matter what the pattern is. So I'm sure if you said it has to go in a particular pattern, it would work out that pattern.
Yeah. So what we just saw, pretty impressive.
Mm-hmm. Yes.
We've got this robot now that's now able to 1.5, which isn't bad. Okay, 1.5 times instead of 2 times sped up the video.
Still good.
It's getting faster. Be able to grab things and move it down. You can't tell me that you can't now take this bot and have it working today in a factory. I mean,
you can have it working in the factory. You can have it doing things, and it may be fast enough to actually take over one particular job, or it may be that you need two. And we've talked about this before. The operators that are responsible for 2 stations are quick enough to be able to do both those. Is Optimus quick enough to do both of those? Or would you have to have one for each of them? But yeah, I think it's clearly there. It looks like it has its dexterity, the ability to do it. There's plenty of jobs there already. And I think I already know what the first job is going to be. And that's what we see in the next part. So the next part is very interesting. And again,
Yeah,
I was not surprised to see this.
Yeah, before we get there, I want you to show me what's going on with the hands, because these hands are not the hands that we've seen before, right? Is there some sort of glove?
I think they are. I know you mentioned it. I looked at it as I didn't really see anything different. Are you not? Maybe it's a perspective from that camera makes it look a little bit odd.
It's white. It looks like a glove instead of I think
it was always like kind of that material. It was there. There's the sort of the gloves that we see and the Opticons that are out there that are very shiny, or the hands on those things. And again, those are more or less mannequins. These, they always seem to have that funny gray coating on top of it. So I don't think they've changed radically. If they have, they've obviously made improvements and tweaks along the way, because they keep on mentioning that, there are these improvements that they're doing.
See, I don't know. When I look at it, it looks like it's metal, but now it looks like it's kind of, okay, maybe I'm wrong.
Yeah. It's hard. I've always seen them as looking like they have some sort of non-slip coating or something on there, something a little bit different. Yeah. And you might be right that some of the earlier ones may have seemed a bit shinier, but I think the most recent ones we've seen kind of look like that.
Okay. So this is pretty impressive, as we've said. Okay, so then you said the last part is very cool. Tell me what's going to happen here. So that's
unpacking and everything else. Okay, so here, what's very impressive, if you remember I think it was the Shareholder Day video where they showed the improvements to the control system. Yeah. And the egg not being broken by the leg. So it was able to come down and stop right away. And so as soon as I saw that, it's like, wow, they've got such fine control and finesse. We're going to see some pretty neat things on what it's going to be able to do. We had also heard rumors of the idea that Optimus should start doing more gymnastic kind of things and be able to show what it can do, because it probably has the capability to go faster than 5 miles per hour. That's going to be a software lock more than anything else. It probably has enough power everywhere else to do a little bit more. And so looking at this is very impressive, because it's full body control. It's all the joints understanding the relationship to the other joints and what has to be done to be able to do something. So it's very nice to see that the bot is using and exercising everything there. And when I look at, so there, the balance is exquisite, because it knows it needs to counterbalance that very heavy torso that you have with the leg and line it up. And when you do this motion here very, very slowly, you'll sort of see everything extends out. And then at the very end, the whole body fixes itself.
Let's see.
And then the plant foot. So just back up a little bit. Yeah. So you'll see that the plant foot will then just shimmy forward a little bit. Once everything gets kind of frozen, and then see it kind of rocks a little bit forward.
Yeah.
And what it's doing is it's trying to get the center of gravity a bit more over the center of the foot. So rather than it being maybe the center of gravity might have been kind of back on the heel, it's just moving itself to a far more stable point, because it understands that relationship. Probably means they have a certain sense of some sort of pressure sensors down there, or just the feedback that they're coming. They have an idea where that center of pressure is, and the fact that they want to move it. And then again, here is a very nice yoga pose that's going on there. What I like about that one, we freeze the very last frame, is look at the plant foot. So when you look at, see where it's planted, you're going to see that the angle of the ankle. You see it's not straight up.
Yeah.
So that's the reason why you also need what is that little bit of what's foot roll there, kind of akin to the yaw that we talk about in the hand, as being just a little bit. And you have a little bit of that on your foot. So that's usually the way your ankle moves when you sprain your ankle on something. It's like, whoop, it's that kind of motion. And you don't have a whole lot of that in your ankle. You have just enough of it to allow you to walk on uneven terrain and to do a pose like this. Because to do a pose like that, to be balanced, you need to have that leg leaning over. And if that leg is leaning over and that foot's going to be flat on the floor, you need that. So again, it shows the importance of that kind of nimbleness in the ankles to be able to walk where humans are able to walk and do those. So now the question is, what's the first job going to be?
Wait. I'm still shocked that it's flat foot. Remember, we've been talking about this? They still kept it as a flat foot. Yeah. They still have it. So they have, and again, it might be they don't see there being much advantage to doing it right now, and it may slow them down.
And if you remember some of the sections in Walter Isaacson's book, when someone was, or a couple of the engineers were obsessing about the display on the head and what they should have on there and trying to come up with a deluxe interface and everything on that. And Elon says, that's not important. Just, no, don't worry about it. Next version of Optimus. This one, we want to get up and walking, doing everything else. Probably the same thing with the feet, is they can get an awful lot done with the feet that they have right now. And then they might be looking at improving the feet in the future. So maybe Optimus can run. So maybe it will be able to go, 10 miles per hour instead of 15 miles per hour, or being able to do other things, or maybe to be able to walk a little bit more efficiently as far as energy usage. But for now, they're probably saying that's good enough. And if you'll notice, all of the other humanoid robots out there also have very flat feet. But the one thing I will say, based on this, 2 years ago, Tesla had nothing. Absolutely nothing. And they were starting to put a team together. And they put together a team of engineers that really didn't have any experience in building walking robots or anything like that. And so they dug in, they did the research, and then, what was it, in about March or April of not last year, but the previous, so it was 22, they finally get the first steps out of it. And then it would be falling over and everything, and just moving its head would cause it to lose its balance, which is why they took the movement out of the head. So they didn't have to worry about that. And then to go from that to the motion control to have this in a short period of time is amazing, because everyone else has been working on this problem for decades. And, there may be, you might say, well, there's still a few that are ahead of them or a little bit better than that. It's like, yeah, but boy, they're moving fast. They are moving very fast. So the progress you're seeing in a matter of months has usually been taking other people years. And I'm just trying to think of where are they going to be 6 months from now and 12 months from now when they really have everything going. And I believe a lot of it is the fact that they are getting out of the business of writing heuristics for the control of the body, and they're moving straight into nets. So the neural net understands the whole body. So when you move this arm, everyone knows what they have to do to make that arm move correctly. And if you think it's not important, what you have to do is this thought experiment. Is if you're absolutely weightless in space, and there's a target maybe like right in front of you, and you want to hit the target. And so you throw your fist at that target the same way you would on Earth, on the ground. And when you do that, you're kind of shocked to realize that your body is starting to suddenly like rotate the other way, a reaction from it. And your hand completely misses the target because of the reaction force. Because we're not used to the fact, because it's so innate and so instinctive to us that when we are planted on the ground, our legs know what to do to make sure that our arm is able to go for that target. So everything is there, and it just happens. It just happens naturally, and it happens really quickly. And it doesn't happen that like, well, I'm going to calculate with this arm, figure out what the reaction forces are, and now come up with my model that then heuristically figures out what the torso is going to do, and then what the legs are going to do. And all that's kind of slow, and everyone's kind of behind the game and where they're supposed to be. Instead, it's just like, I know you want to throw that right hook. If you're going to do that, this is what you're going to do with the rest of the body. And it just goes right on through. So that's why it looks so smooth. That's why it looks so natural, because they're using training data. And I think more than that, there's probably some other outputs and parameters they're looking at as far as making sure stability of the bot's not falling over, and also power consumption, because evolution has trained us to do all these movements to maximize the expenditure of energy. So we run a particular way, our bodies were designed a particular way because we are able to not expend that much energy, which is why we're able to hunt down wild animals, because we could literally run them to exhaustion, because we were more efficient runners. Even if we weren't the fastest ones, we could run and run and run and run. And so again, that is one of the things that you want to do with Optimus, is that you're not going to have it be very inefficient, or the neural net can be making sure minimize around this thing. And it's going to find these movements that minimize it over time. And that comes through a lot of, really good training data and being able to crunch the stuff. So boy, I wonder if they got Dojo up already to be able to help with some of this stuff.
We'll talk more about how they trained it, but you've just said that you think that the way that the body moves has also been trained through the video, just watching and learning how to use its own body.
I think that was reinforcement. There's a bunch of other things. So there's not like one thing that goes in the training set. There's a variety of different sources. Because if you rely on one, you're probably going to get things that just don't work very well. And if you put the other things in there, they can all do like this positive reinforcement of everything to make sure you get the kind of movements that you want. And that's why it looks so smooth and natural. And this is why those of us who look at that short video are so excited, because we all point out the same thing. It's just so natural how fluid it is. The decision it has to make when it realizes the block moves, it just naturally goes over there rather than even pausing and say, oh, what am I supposed to do now? And seeing it calculate, it's like, no, it just went right to the target, just so smoothly, exactly the way we would. So the ability to change or make new decisions on the fly is amazing.
Yeah. Let's see here. This is Milan Kovac, who is actually the leader of Tesla's AI. And he said, we've made quite some progress on the AI side, on our way to make Optimus help with repetitive, boring, and dangerous tasks. Very proud of the teams. And then Ashok Alaswamy, he says, neural nets and cameras work amazingly well and are really the solution to robotics. Same solution for the car, for Optimus, and will be for all such artificial animals. So a few things here. Ashok Alaswamy is in charge of Director of AI, and he's pretty well confirming that neural nets with cameras work really well and are the solution for robotics as well as AI at the car. And then he says, will be for all such artificial animals. I read that and I kept trying to read it over and over again. And was he just being funny? Is he saying that there's going to be other animals, other forms? What is he saying here? What was your take when you saw this?
Yeah, I mean, there's so much reading between the lines. So the first thing is Milan should be very proud of his team and himself. He's done an amazing job putting that team together and running it. And he's more or less, let's say, responsible for the mechanical part of it. And I'm sure a lot of other things. And Ashok is, really, he's the AI guy. So he's responsible for the bits that are going not only to the car, but into to Optimus. And they realize that the solution that we have for FSD applies really well to Optimus. So and he was saying the car, Optimus, and artificial animals. And now what is he saying in general? That's the solution that all self-driving cars have to be, not just Teslas, LiDAR and all these other things. Forget it. That's the way you're going to do it. So maybe he was being kind of tongue in cheek about that, saying like, if you're going to want to solve it with a car, that's how you do it. If you want to solve it for Optimus, you want to do it. And any other artificial animals, which could mean other humanoid bots or like little robot dogs and other things like that. So now everyone's wondering, and we're sitting here speculating, does that mean Tesla is thinking of making a robot dog in the future? I don't know. I don't know if that's reading too much between the lines. What do you think?
I mean, the answer is of course. Of course they are. Just because
maybe
they start with a car, now then humanoid robot doesn't mean they're going to stop there. They've always said, right, that this is basically artificial intelligence, real world AI, that the car is a robot. Then this is a humanoid robot, but doesn't stop them from creating all sorts of different kind of robots, whatever needs to happen. Because now you can make my vacuum cleaner. If they're going to make a vacuum cleaner that's going to be so smart, forget the Roomba. My gosh, you can have a vacuum cleaner that's going to be so smart and be able to do things without, you can just train it through video.
Yeah. I mean, it'll be more than a vacuum cleaner because it'll actually be able to do the stairs and the drapes and everything else that the Roomba can't do. So you're right in that when you have these artificial animals that they're talking about, they're going to find applications. And everyone said, why the humanoid form factor and everything else? Because we're going into space where humans are. But if we want to go in spaces where humans generally aren't, then we might come up with a different form factor, or there may be a slightly better form factor for certain jobs and applications. Warren Redlich has sort of said that, what's the bot going to be look like for roofing? Because I agree, roofing is really hard. It's something great for a bot, but it's not great for a humanoid bot because it's not good for a human either. I mean, it's very hard. So you may come up with something that's more of a quadruped that's able to do it, that's a little bit different, but it's just really good at roofing. It's not something else. So you're going to get the specialization. You get the specialization in industrial robots anyways. I mean, everyone thought, well, you just build one industrial robot and it'll do all the tasks. It's like, no, there's no such thing as a general purpose industrial robot. There's spot welding robots and there's arc welding robots and there's painting robots and there's PCB robots and these they're always different. So you're going to have these different form factors. But the thing is, they've decided this is the most important one to start with. And eventually it's going to change once they figure out the artificial intelligence bits. And then, you may have some Optimus versions which are on wheels. I know that I keep on saying you want to be legged at first, but you will have some that'll just being wheeled will make sense.
You said earlier, what is the first application, first use case for this? What was your?
Yeah. So it's already for the factory, I think, right now. So let's go to the very last one.
What do you mean, last one?
Mm-hmm.
Sorry, what?
Yeah, so the very last frame of the video is the first use case in the factory. Because remember, Elon says something useful. The first time we'll be able to do something useful in the factory. And the one thing I think is useful in the factory, you think about it, when you work in any sort of factory, in the mornings when they come in and get ready, the workers go out, or they get a little bit stressed out. It's not bad to actually have someone teach them a little bit of yoga. So I think what's going to happen
You really think so?
Optimus is going to lead the yoga classes in the Tesla factories.
Come on.
There you go. That's the first application. See, ready to go. He's ready.
No, okay. I don't believe you. I don't agree with you, but okay.
The first application, if it really is going to be like we say. It's going to be loading the spot welding robots.
Exactly.
Those cells. That's probably one of the very first applications, because Elon has said that over and over again. And usually listen to him and listen to everyone else around him that says the same thing. That's what they're going for.
Okay, let's go through what Jim Fan said. So Jim is the AI for NVIDIA, and he said that.
Yes, I think he works at NVIDIA, and so he has a pretty good background. He's written several papers in the area.
Said no insider information. This is just his own analysis. So first, he talks about the smooth hand movements are almost certainly trained by imitation learning, behavior cloning from human operators. The alternative is reinforcement learning in simulation, but that typically leads to jittery motion, unnatural hand poses. So he thinks this was behavior cloning from human operators. Any thoughts on that?
Mm-hmm. Yeah, I sort of agree with that, and that he notes it is very, very smooth, which is something else, and that humans just have a certain finesse when we do our movements. And the question is, how are you grabbing that data? So I would think it's probably a combination of both, that you start out with a simulation so you don't have a blank slate, because sometimes it's a lot easier to reinforce the learning on something that you at least have there. And then the human pauses would come in and make it smoother and smoother. So yeah, he didn't notice any jitteriness in there. Neither did I. Everything was kind of smooth. So you would think that it probably had a pretty good data source. And that could be looking at videos of human motion. That makes sense.
So this part surprised me because I did not know this. So I learned something new. He said that there's 4 ways to collect human demonstrations. There's a custom-built teleoperation system. You and I have covered that. We've shown this many times. Tell me more about Aloha.
Okay, so it's this one up in Stanford that I believe we saw one of these videos several months back, where they had this teleoperated robot that was doing things like putting on a zipper, taking the cover off of a jar, just doing a lot of things that required a lot of dexterity. And he's talked about, like the same thing, AAA batteries into a remote, or manipulating a contact lens. Something that seems very difficult for a robot manipulator. And these hands were not the best hands. I mean, you look at them and it's like, that's not at all the way I would design a robotic hand. The main thing was that they had the teleoperator. The key was a teleoperator was going over and able to do the finesse, and they were able to get the learning from that. So that's opened my eyes up on what you can do with the robotic hands. They don't necessarily have to have what appears the same kind of capability that we expect in a human hand, especially when you couple it with a vision system. So, so I definitely agree that that's one way you'd be able to do it, because we've seen a lot of others doing that as well. And that's one way of being able to capture the motion. And then he goes on with some of the others that are also very traditional methods for motion capture. The ones that are used in Hollywood, which are a bit more expensive and a bit more intrusive to do, but it is a possible way of doing around that. That way you don't need to have hardware. You might do some sort of motion tracking devices by putting dots all over your fingers that can be easily picked up.
Cyber glove.
And then, of course, there's a cyber glove. That's another way of doing it, where you put it in there and it basically measures the joint angles of your hands right away. So a cyber glove or a data glove, they've been around for a while.
Okay. So there's that motion capture, and then there's same wearing gloves and markers can be clumsy. So an alternative way is computer vision, which I think that's what we saw, wasn't it?
Yeah. And yes. So if everyone remembers the Kinect system years ago, that was a Microsoft that kind of came out with that. And again, it was using a camera-based system to try to track your movement, to guess what your movement is. And so that would be definitely another way of being able to do it. And that, NVIDIA has a card specifically designed to be able to do something like that.
And then the final is VR headset, which is the one I've been talking about for quite a bit.
Yeah. Yeah. So you have a VR headset and the hand controllers and the normal trackers you have for that. And with that, you would have a model and being able to move it around. And so those are all different ways of being able to generate different sort of data streams that you would want to feed in there. And I think the conclusion he had is that it may be, above 4, not mutually exclusive. Optimus can use it. And I kind of agree. And I think combining them, you get better result than just relying on one. Because then the strengths of each of them, you can take advantage of those, and it kind of covers up maybe some of the cons or difficulties of the others. So a lot of times more than one data stream would be better. So I definitely agree with that conclusion.
Yep. Then the second part of his long tweet, he talks about the neural architecture. Optimus is trained end-to-end, videos in, actions out. And he goes, I'm quite sure it's implemented by multimodal transformer. And then he talks about image, video, and then he talks about language, and then action tokenization.
Yeah, so for just a second here, you talked about like tokenizing everything, and then the video is going to come in. So from the video, you're then going to create these actions that are going to go out as tokens. They call them tokenized actions. And then when I was reading that and looking at what was on there, I said, ooh, deja vu, this reminds me of something. Didn't Google have a paper about this about a month ago of doing exactly that? And of course, that's exactly what it says. I believe the architecture is most similar to the Google RT1. So now in that is like one sentence here that I absolutely love that gave me a piece of insight that had not occurred to me before. So it's that the next frame from the table is fed back to the transformer. So remember, the whole idea of a transformer is to attention is all you need, is to sort of keep track of the conversation and know what's important. So that's fed back to the transformer so it knows the consequences of its action. This gives the self-corrective ability shown in the demo. So the whole idea is it's not forgetting what's going on in the conversation. That's the whole idea of a transformer. That's why ChatGPT can work the way it does, is because the transformer is able to remember so many tokens. It understands what's going on in the conversation and remembers what you told it 5 minutes ago. So doing that is like, because a lot of times I'm always thinking of the forward movement, the future movement, where I want to go in the future. But a lot of times where you want to go in the future may somehow be based on where you were in the past. And if you immediately forget where you just came from, it may not mean you know exactly where to go next if something changes in the context of your conversation. So I agree with him on that. And that was like a great insight that I hadn't thought of, like, how does a transformer kind of fit in here? And it's like, now I know. So thank you, Jim, for that.
Yeah. And then the final thing he said was he's genuinely impressed by the hardware quality. The motions are fluid. The aesthetics is amazing. And as mentioned above, it's such a great decision to follow human morphology closely so that there's no gap in imitating humans. Because at Atlas from Boston Dynamics, they only have the gripper-style hands. In the long run, Optimus's bidextrous 5-finger hands will prove far superior in daily tasks and all the motion, the degrees of freedom you've been talking about. So, yeah, what's your thoughts on this?
Yeah, I agree. The closer it is to a normal human body, it helps. I know there was a big discussion in Tesla when they were designing the hands, whether they should just do 3 or 4 fingers. And then they realized, we really do need the pinky in there. And so they decided to go with the 5. And again, that's kind of the point, is that if you're trying to give it training data and the hands all have examples of 5 fingers, then it would be nice to have a bot that also has 5 fingers to be able to understand it. And so the morphology is very close. It's not perfect because we don't have the neck in there. So hopefully it's not really worrying about that. But as far as the hands, I think that's very important, because the hands is way more important than the neck when it really comes down to it. So you want to make sure that it understands the same kind of movements that you need to get, and it's able to demonstrate or be able to produce that capability.
What we've been saying for such a long time, and it's becoming much more clear from watching these demos. They've spent so much time on the hands, the dexterity, the movement, the ability to grab and fold. You can see in this demo how incredibly smooth and fast it can be, and so forth. And then they spent a lot of time in the AI. Of course, it needs to be able to learn and be able to react. And how quick this has happened so quickly is amazing. Whereas other companies that you and I have done so many videos on 10 plus bots, and we've looked at them very closely. And this is where they're focused on. So the head movement or the feet being flat, it's still something that they're going to work on later. Right now, this is really the focus, is this dexterity of the hands. So then I wanted to share that we do need to address this. There was a Tesla Q kind of came out and said, hey, did you take a look at this part of the video when you can see this block moving in a weird way? And they're kind of saying this is CGI. This is clearly. So let me share that video, and then we'll share the counter video to that. So if you watch this as he moves, that block looks like it just moved on its own. So it looks very much like it's a CGI. That's a proof that this must have been kind of like mocked up. Now, this other person here shared this video, this kind of write-up, Tesla Mojo, said haunted blocks, horizontal gravity, splice video. No, it's very simple. Watch below, and he crushes those arguments.
Right.
And so he basically shows
block and now is being moved out of the way. Once again, two distinct objects can't occupy the same space. So the pinky has been compressed and has moved that block out of the way. Now it's been dropped. So you can say that, oh no, there's horizontal gravity, or oh, this has been clipped. Now, if I just go back and forth, you can see there's no clip. There's also a human in here. If I zoom out, you can see there's a human in this clip as well, right? There's nothing, if we look at the background, there's nothing in this clip that makes me believe.
Okay. So he's basically slowed it down, took a look at it closely, and it looks very much like, no, that was not CGI, because the fingers was holding it. And then, yeah.
Right. Now, if you're doing CGI or something like that, you wouldn't even have the blocks come closer. I mean, it's so easy to make something in CGI where you don't have the blocks coming into conflict in the first place. So why create a controversy when you don't need one if you have complete control of the world? Like I say, my complaint was like, why is Optimus trying to kind of put the blocks very close to each other where they collide? So that's something that's going to have to work out eventually to not do that. So I will add to it that you don't need artificial gravity and you don't need like haunted blocks, but there's this other really mysterious thing out there. It's called impulse. It's a result of impulse.
What's impulse?
And yes, so what impulse is, and anyone who's a physicist knows exactly what it is. It's also momentum transfer. And pretty much, you know, momentum transfer we're used to when you play pool. You know, one ball hits another and that thing kind of goes off. And usually what we're used to is that if the two objects have the same mass, then when they kind of hit, they kind of go off with sort of the same relative velocity next to each other. And you notice that one block kind of skips off really fast when it was hit with the other. So you would say, aha, I mean, how can it move so fast when the block that hit it is moving so slowly? Well, that's because the block that it was moving with so slowly was attached to a very big, heavy robot. So it's the mass of the entire system. So when that little blue block hits the other block that's not connected to anything, there's a huge momentum transfer in that instant because those blocks definitely come into contention. They hit. And that's why it's going to rocket off, because it suddenly got a jolt or impulse. It hit really quickly with something like that, which made it kind of jump off.
Okay.
So it's as simple as that. You know, something's really light, gets hit with something really big, and the little light thing just goes zipping right off, and the big thing kind of sits there like, you know, nothing hit it.
Okay. Well, I just wanted to share that.
Again, you're seeing physics being demonstrated, and I bet if you did that in CGI, you'd have a hard time getting that physics right.
I just wanted to share that because I wanted to be as objective as possible, but just we don't have to spend time on it. You know, let's just step back and think. So you and I have been following TeslaBot very closely, as many people have, but you and I have done many videos on TeslaBot. A lot. And now we got a little drop here of this incredible video. And, you know, just objectively, are you surprised how quickly they've been able to accomplish what they're doing? Are you still expecting? I know they said that by November, Elon was guessing that by November they would settle down on the design of the actuator, and once they have, that they're going to start building it in scale. So very likely by next year they're going to be building lots of bots. And I don't know, in another video I just did with Jeff Lutz, we just shared 50 plus jobs that Tesla's hiring that are all around Tesla bots. So this is moving fast and furious. What's your state of the nation at this point?
Okay, this was a bolt out of the blue. I was not expecting that video to drop Saturday. And the timing was kind of fortuitous maybe, because I had other plans for the weekend, which was on Sunday to go to the Florida Mall to look at the Tesla bots there, and the entire Tesla Owner Club Florida kind of came out to see my explanation of it. So that's what I was preparing for, to explain that. And then Cern Basher wanted to come along with me. So we decided to go see the Starlink launch beforehand, Saturday night. And we're in the middle there, and my phone just starts blowing up with everyone says, have you seen this? Have you seen this? Have you seen this? So we ended up spending, till about 2 a.m. looking at things. It says, there's going to be questions tomorrow. And then sure enough, my phone was exploding. John, Tesla Fix, Randy Kirk, they all wanted to talk to me about what's going on. And so I did a couple of hot takes there. And the sound quality wasn't good because I was just not in the right environment. But yeah, I was questioning the timing. Why now? And it's like, we're expecting this in November or around AI Day or something else. But it's just like, why do they suddenly drop this right now? And I think part of it is because they realized, hey, it hit a major milestone. And they didn't want to keep a lid on it and say, we want to talk about it. And of course, they want to recruit. So, I mean, it was more about recruiting. And that's also very bullish because it's saying they've probably got the bot up to a certain stage that maybe now they really need a large number of people to come in to start working with it to get that training set up, just like you need to also have a lot of FSD drivers. But until you get FSD to a certain state, you don't need a lot of drivers. You just need kind of enough to find out what's going on. Now they're ready to get it going. So that's, to me, is a bullish sign. Some of the other responses that Elon made, one of them was about the motors and the design. So he says they're tweaking or changing the motor designs, which is great. I don't know what they're doing, but I know he said they're going to be doing that. And also some of the mechanics. So they're already thinking about what they want to do next, which is also kind of great that they've learned a lot. And, there has been indication already. They said they're getting ready to ramp up. So I really believe they are going to ramp it up. It's not going to be that difficult to have a ramp up or to build a factory for this. And so my expectation is, early next year, you're going to start seeing large number of bots being produced each month for whatever purpose they have. Now, that factory is going to be one of these that they'll be able to kind of dial it up or dial it down, whatever we want. So they're going to be building it very much like agility is like, oh, we want to build 10,000 or whatever it is, but we're not going to be building that many right away. We're going to be building what we need because we have to be able to absorb those bots, get enough of them out there, get enough of them tested, and have enough jobs for them. So if we produce 100,000 like that, and there's like no place to put the 100,000 of them, then you're kind of spending a lot of money unnecessarily in a lot of production. So I have no idea what their use cases are like. Whether they say, oh, we can only do like 1,000 things next year. That's it. We only got to, and that's it. So that's all we're going to make. Or maybe they already say, wow, we've got a place for 10,000. So that they could easily, I bet, ramp up to do that because they're ramping up the actuator line right now. They're working on it. That's what Elon had talked about.
Well,
and when
Tom
that's,
June
and remember,
said,
you need 40 of those per bot. So that is the bottleneck right there. You need to be able to produce those. And if you're able to produce them, just like if you can't produce the batteries, you can't produce the cars, right? The cars are the easy part. It's the batteries that's the limiting factor. And now if we go ahead with the actuators and maybe I'll come up with a channel called the limiting factor 2, and it'll just be about actuators instead of batteries. So something like that. So once that's scaled, the rest of it's going to be easy. And then you'll have this very assembly factory. And I was thinking about this today, partly because, how is Agility going to be setting up their factory? What are they going to have it doing? Say, okay, if you had a factory and you wanted to design it, would you use like an unboxing method, or what kind of method would you use to have bots assembling other bots? I began to realize the layout of this factory is going to be a little bit unconventional and different than what we're used to. So the idea of the assembly line that Henry Ford came up with was really division of labor. That the whole idea is that one person does one job and that's it. And I know years ago, Volvo had experimented with this idea of having these teams where people were like responsible for putting the whole car together. So they weren't just doing one thing the whole day. They get to almost like put the whole car together. The thing is, you could not get that to run very fast because the setup time between this operation and that just wasn't efficient enough. So the assembly line, the best thing, division of labor, you just focus on one job and just do that. And you just keep on doing it really, 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 really well. But there's always this problem that when you're done with your task, it's handed over to someone else. So you need a conveyance method. You need all these other things to be able to do it. So if you were to configure a factory for it, how would it be? So I was imagining, okay, let's imagine there is no bot. And what's the best way to put it together? So there's two ways. One, you put it on a gurney, pretty much like we saw in that other video where the two bots were putting it together. So it's like, oh, it's an operation that's going on here. But the other way of saying is like, well, a lot of these when you look in these labs, you always see that the bot's kind of hanging there on some sort of scaffolding that they're kind of setting up, and then they're kind of operating it and connecting everything that way. So, well, that's one way of doing it. And we know Optimus is able to hang pretty well from the head. So it's got something like that. And I was thinking, it's almost going to look like a slaughterhouse in reverse. You know, I'm going to have these meat hooks, and then there's going to probably be a station at the beginning where people are going to sit down and they're going to try to design, or let's say they're going to put together the torso. So that everything goes to the structural battery pack. You put everything in there. And maybe it's very complicated, and it's a human that's doing that. And when the human is done, and usually when you're done with any sort of task, you either you have to hand it over to something else to convey it away because it's done, or a mobile robot or something like that. In this case, it might be when they're done, they just kind of put it up on some sort of, well, look like a meat hook, but basically it's overhead hanging conveyor, and then it's going to kind of move along. Okay, so now it's along their torso without the limbs. And all you have to do is just start bringing the limbs in and assembling them, and it just moves at a slow pace. So the limbs have to come from somewhere. So normally you say, well, we've got somewhere over there that's producing this sub-assembly of the different limbs. You know, different people are putting it together and they're handing it off to somewhere else. And then when the limb's done, what are you going to do with it? Well, do we put it on a conveyor and then just have like this conveyor line feeding that other line at some point that someone kind of grabs it off the conveyor and puts it up there? Or, well, do we really need to do that because the production volume's not quite that high? Maybe we put it on a mobile robot instead. And the mobile robot goes on over there. And I'm thinking more about it. I say, wait a minute. You know what would make more sense? It's like an Optimus is sitting there putting together the arm. And rather than putting it onto a conveyor or putting it onto another mobile robot, it just picks up and walks it over to where it needs to go. And it stands in a line maybe with another Optimus that already has its done. And the one that was done with that just kind of walks back there. And so basically they go around almost like, you know, what do they call it? The fire line there, or, you know, and you would optimize the number that you have there to go ahead and work on it. And then, you know, the other one kind of brings it there. So they are tag teaming around back and forth, and they can do any operation in the factory, because it's not like a human that you have the problem with this context switching. It's like, I've got everything. Why do I have to hand it off over here? I'm just going to walk it over and put it on there. Now, for some reason, you're producing arms much quicker than you are legs. So what happens is one of those Optimists goes, oh, we got too many arms. I'm going to go over and help the guy with the legs. And so the whole thing is just going to self-balance.
That's fun.
And they'll go over and they'll do that. So my prediction is the line is going to have, the only conveyor may be, and it's either going to, if they go with the unboxing method, it's going to be not hung on a meat line, but it's going to be just hung on a scaffolding. And that scaffolding maybe gets pushed off to somewhere else like we do in the unboxing method. And then whoever has it says, hey, let's go on over here. And like goes over there and puts it on there and goes back and says, hey, we're running out of legs. I'm going to go over to the leg line right now and work on that. So they will be moving around, or it's moving that way. But there won't be any conveyors. There won't be any mobile robots. There may be a few humans here and there that are doing something that Optimus is not ready yet. But I'm just thinking that there's so many things. And there may, and of course, it's assembled. It goes to the test station like they're showing, and then it goes ahead and puts it on there. So that's kind of how I think I would configure it, and realizing that,
sounds right.
Man, think outside the box. Just completely think out of the box on how this thing is going to be set up. And you might look in there and it will be such a lean design because, wow, they just disrupted conveyors and mobile robots. And that's the way old things used to be built, you know, in a carpenter shop or something like that. You know, you worked on something and you walked it over and you put it up until it was on your wire. There was no conveyor in your basement. There was no mobile robot. You did it all because you could do it all. And Optimus can do it all. And Optimus can switch tasks like that without having to say, oh, well, how do I do this?
Maybe the Optimus can actually build itself.
Yes, it will. I mean, it will be doing.
You put the legs on,
you know,
and then it's off.
Yeah, so there'll be
the rest of the parts on.
Obviously, there'll be traditional manufacturing lines for like the actuators. So you know, they'll be being pumped out, and somewhere something will be running. Whatever is making the plastic injection moldings for everything that they have, whether that's in house or something like that. So there will be bins of parts and everything else. But at some point, they need to be assembled. And Optimus will probably be able to do a lot of that assembly. And there might be some fine assembly that you still need to have a good technician go ahead and do that. But once that gets to a certain stage, it can get handed over and the Optimi can just come in and just start assembling everything and going ahead and putting it up there. Like I say, that factory will self-organize itself instantly.
Makes sense. Yeah. And you and I have done a video already where you showed that the head is empty. And the reason is because they have this metal thing that some hook can grab onto and move them around. And that's why they don't have an actuator on the neck.
Yes.
And you showed that it's almost like that football shoulder thing to keep it very strong, won't be able to break. And that's how they keep it steady. And that's why they did that. That's why it's not like the neck is breakable. It's very strong and stable.
Now, my guess is, a lot of the torso unit will be coming out of Sparks. Whether it comes out completely, I'm not sure, because the batteries are going to be coming from there. And I believe they have the presses that will be probably stamping out the torso, the cavity for that. And then maybe they're already going ahead and putting in there, and they have any electronics and put it in there as well. In which case, maybe the line gets set up in Sparks, or maybe they're sending out kind of a partially formed torso that goes to wherever the final assembly is. And then in the final assembly, you add whatever other bits you need to put in there to finish off the torso. Because part of it is you're going to take 2 of the actuators for the shoulder have to get popped in there. And then like the cameras and the head and everything else. But yeah, you're right. The head, the neck, and the torso cavity are all one solid structure. And then just the actuators that you need to do the mounting points here. And then you would just kind of hang that. And now it's going to be someone else comes in and starts adding something else. So someone will probably add like the pelvic girdle onto there when it's hanging. Or again, we could say, oh, you do it like a gurney, because we don't want it hanging and swinging, or maybe it's difficult. So we just lay it down. Well, it's like a bed, and that bed just moves from one station to another, or it just kind of stays in one place, and then you come to it. It's going to be one or the other.
Okay, that was fun. That was great. Thank you so much, Scott. Really looking forward to you coming in and explaining all this. So we covered quite a bit of ground here. Huge. This upgrade by Tesla. I think that they're going to do regular videos once a month. Remember, he had said at one point, he goes, you really should do a blog, and every month we show what our progress is. I mean, at this point, the progress is going to be fast and furious at this point. They're going to show, just like we saw with that Google, they can show all sorts of activities now. This is just one example, moving blocks around. Eventually, they'll show it to use a drill. Then they'll show it using, throwing a dart or something, whatever. They'll be able to do these things at this point.
I know one use that someone asked me yesterday at the Tesla event in Orlando, and that is like, when is Optimus going to play pool? Wanted to know.
Why? Why?
Well, I mean, you get these pool halls, and a lot of times someone comes in there and they want to play pool with someone, and there's no one there. Now, Optimus will probably be quite the pool hustler. He'll kind of miss a couple of shots. I want to take a bet on this one. But then Optimus can't talk, so I don't know. So
let's stick with what we know. They're going to do it for a factory.
You know what? I bet they can. And if they haven't thought about it, if there's a pool table out in Palo Alto, go ahead and put Optimus up there and see.
They're going to train it on things. The calculations are very simple. In the dexterity, I mean, it's not that hard to hold a pool cue and get it up there and just kind of line up and do that. It's about.
I mean, there's a certain about, but it's not as challenging as so many other things, and it's much easier than playing table tennis. Because table tennis, you've got to be moving a lot faster and everything else, and you get that. I mean, that will also be impressive, but that's a much faster kind of thing. The pool is a very slow kind of thing. You can take your time, you can set up shot and do that, and it's able to walk around, it's able to line it up. I think it has enough dexterity. It's not like it needs to move its neck to play pool. You need to move your neck to play soccer, right? There's a lot of games that you need to do that, but I think, it might be fine. Why not? That's a good demonstration example.
Thank you so much, Scott. That was fun. Appreciate this. Follow Scott on Twitter at GoingBallistic5, and he's always on the show. Every week we do a bot video. Take a look at all the other bot videos we've done. They are very good. Thank you, Scott. Appreciate your expertise.
Okay.
Talk to you soon.
Glad to be here.